students, welcome to the next video of integration. In today's video we are going to see some important substitution, right? We are going to continue method of integration. In that we can see some important substitution. So as you can see in this table, I have almost mentioned all the suggested substitution. So just see, if the question is in the form of fx raised to n into x raised to n minus 1. So we can clearly see that x raised to n is function and in derivative we are getting this term x raised to n minus 1, and hence we are going to substitute x raised to n as t. Okay, if suppose we are having function raised to n, okay, into derivative of function, in that case we are going to substitute this function as t. This means what? Function raised to x. Suppose I am having sine cube x into cos x. Okay, so this sine x function is what? Function is sine x, and I am here having this function raised to 3, means sine x raised to 3, and derivative of this sine x is cos x. Okay, so I am having this term in this form. Okay, so if function raised to n into derivative of function is given, in that case we will substitute this function, means f of x as t. So in this example we are going to substitute this sine x as t. Okay, so second integrand is clear. So if the integrand is in the form of f of x raised to n into f dash x, then we will substitute this f of x as t. Then third one is f dash x upon f of x raised to n. So again in this case, function raised to n and numerator is derivative of function, but since in denominator it is raised to n, hence we can't apply the result here. We are not able to apply the result, so we are going to substitute this part. So again have to substitute f of x as t. Okay, then if it is f dash x upon f of x, then you know we can easily apply the result and we can find this as log f of x plus c. Okay, then next is, if it is f dash x upon root f of x, then we can apply second result and we can say that this is equal to 2 root f of x plus c. Okay, then next is f log x into 1 upon x. Now we know that log x is a function and derivative of this log x is 1 upon x. Okay, so that's why we will substitute this log x as t. Okay, so suppose if it is given as sine log x upon x is equal integral of this dx. Okay, so in this case sine of log x, but this log x, okay, we can take this log x and we know that derivative of this log x is 1 upon x. Okay, so hence we substitute this log x as t and derivative of this log x will be 1 upon x dx. Okay, then next is, if it is f of sine x into cos x. Okay, now we know that derivative of sine x is cos x, so we'll substitute this sine x as t. Then if it is function of cos x into sin x, then we know that derivative of cos x is sin x and hence we substitute cos x as t. So for example, log cos x into sin x dx, suppose this is given. So we know that cos x is a function and derivative of this cos x has a minus sin x, right? So sin x is given, so we take this cos x and will substitute this cos x as t. Then next integrand is f of 10x into sec square x. So as we know that 10x is a function and derivative of this 10x is sec square x. So we'll substitute this 10x as t. Then next is if the question is in the form of integrand is in the form of integral under root a square minus x square. Okay, so in this case we have to substitute this x either as a sin theta or as a cos theta. Okay, if it is, once again I am repeating myself, just listen carefully. If it is a root a square minus x square, so in that case substitute this x either as a sin theta or as a cos theta. Then next is if it is a root of x square minus a square. Okay, here it is under root of a square minus x square. 10th is root of a square minus x square. Then we substitute x as a sin theta or a cos theta. Now 11th is root of x square minus a square. If it is x square minus a square, then we substitute x as a sec theta or a cosec theta. Okay. Then suppose integrand is in the form of root of x square plus a square or only x square plus a square. So in both the cases substitute x as either a tan theta or a cot theta. Okay. If integrand is in the form of under root of a minus x upon a plus x, then substitute x as a cos theta. If integrand is in the form of under root of a minus x upon x, only x, okay, not a plus x, not a minus x, only x, then we substitute x as a sin square theta. Okay, if the integrand is in the form of under root of a square minus x square upon a square plus x square. Okay, no, both are not minus, then numerator is minus and denominator is plus. In that case we will substitute x square as a square cos square 2 theta. Okay, and if integrand is in the form of root of 2ax minus x square, then we substitute x as 2a into sine square theta. Okay, so these are the some suggested substitution which you have to just revise. Okay, then you can easily understand this. As you can see here, function and derivative of function both are given, so we are using the function as we are substituting the function. Okay, then these are the some terms, as you can see in left hand side, these are the terms which you can easily find in this trigonometry formula. Okay, so basically it relates with the trigonometry formula. If you are having a better understanding of trigonometric formula or trigonometry chapter, then you can easily relate this part. Okay, the substitution is totally based on the trigonometry formula. So now let's see the example. So first example is evaluate integral dx upon root of a square minus x square. Now as you can see here, it is as you can see here, it is root of a square minus x square. So in that case either we have to substitute x as a sin theta or x as a cos theta. So here I am substituting x as a sin theta. Okay, if x is a sin theta, then now see very carefully, I am substituting this x as a sin theta. So that means sin theta is equal to x upon a, right? Now this theta, I am taking this sign on right hand side. So theta will be sine inverse x upon a. Okay, once again I am substituting x as a sin theta. That means sin theta is x upon a. So that means theta is equal to sine inverse x upon a. Okay, now I am going to differentiate this with respect to x. Now I am differentiating x with respect to theta. So what I will get? I am differentiating x with respect to theta. So dx is equal to a into cos theta d theta, right? See, I am differentiating, this is x is equal to a sin theta. I am differentiating this with respect to theta. So dx upon d theta, that is equal to a, as it is derivative of sin theta is cos theta. So what I am getting? I am getting dx as a cos theta into d theta. Okay. So dx is equal to a cos theta into d theta. So now I is equal to dx, but dx is what? A cos theta into d theta upon a square minus x, but x is a square sin square theta. Okay, now here this part, this denominator part, from this denominator, just wait, let me clear the screen. Okay, now see, denominator is under root of a square minus a square sin square theta. So that is equal to under root, a square is common, so 1 minus sin square theta. So that is equal to root a square 1 minus sin square theta is cos square theta. So root and square cancel, so that is equal to only a cos theta. Okay, so numerator is a cos theta d theta, denominator is a cos theta, and a cos theta cancel, so it will be only integral of d theta, means integral of 1 d theta. So integral of 1 with respect to theta is theta. So theta plus c. But theta is sin inverse x upon a. So hence final answer is sin inverse x upon a. Okay. So these are the some special cases, special type of substitution which comes under the method of substitution. See one more example, integral x upon root of a square minus x square. Again see, denominator is root of a square minus x square, right? So again I am going to substitute x as a sin theta, then same procedure, that means sin theta is equal to x upon a, right? So theta is equal to sin inverse x upon a. Now since x is a sin theta, I am going to differentiate this with respect to theta. So I will get dx, which is equal to a cos theta d theta. Now again I am going to substitute this in I. So I will get a sin theta upon root of a square minus a square sin square theta into dx. dx is a cos theta d theta, right? Now a into a, so it will be a square sin theta cos theta upon denominator is again a cos theta d theta. So a cancel, cos theta cancel, so finally I am getting a sin theta. So a is a constant, so it will come outside the integration and it become a into integral of sin theta d theta. Now we know that integral of sin theta is minus cos theta. So I will get minus a cos theta plus c. Okay. Now this cos theta, right? This cos theta, I am writing this cos theta as root of 1 minus sin square theta. Okay. So minus a under root of 1 minus this sin square theta. Sin square theta means x square upon a square. So 1 minus x square upon a square plus c. right? Now cross multiply, so it will be a square minus x square upon a. So a cancel, so finally that is equal to minus root of a square minus x square plus c. Okay, so this what I will get after simplification. If I substitute theta here, that it become a very complicated part. Answer will be minus a. First let me clear. If I am substituting theta here, then I will get answer as minus a cos, then theta is sine inverse x upon a plus c. Okay, which is not clear. So for that, to simplify this part, what I am going to do, I am going to convert this cos theta as 1 minus sine square theta, and then I will substitute this sine theta value. Okay, and finally I will get the simplified answer. Okay, so this is the part of substitution method. Okay, so with this I am concluding this video. So thank you students, thank you very much.